Hello, this is the section 7.1 lesson. In this section we're going to talk about the idea of ratios and proportional relationships. Start off with an informal definition of these terms. So a ratio is a type of relationship between two quantities. And this relationship is also called a proportional relationship. And we're going to use these terms ratio and proportional relationships interchangeably. The important thing to remember about a ratio is that it's a relationship and there's two quantities involved. So as a simple example, let's take this baking scenario. A muffin recipe calls for 7 cups of flour and 2 cups of milk. So notice that we have two quantities here. We've got our 7 cups of flour and we also have 2 cups of milk. So we have a relationship between two quantities. This type of relationship forms a ratio. Now there's different ways to describe this ratio. First of all, we could describe it in words. We say the ratio of flour to milk is 7 to 2. We could also describe it with a colon. We say the ratio of flour to milk is 7 to 2. Thirdly, we could use a fraction and say the ratio of flour to milk is 7 over 2. These are just 3 different ways of describing the same relationship between these two quantities. Now our ratio describes how to make one batch of this recipe, but suppose that we wanted to make more than one batch of our muffins. So a question we might ask is, well, just how much flour and milk do we need? Now there's different ways of answering this question. The way we're going to illustrate here is to form what's called a ratio table. So to form our ratio table, we're going to make a table that consists of 3 rows that go across like this and several columns that go up and down like this. In each one of these rows we're going to put our different quantities involved. The bottom row will put our number of cups of milk, the second our cups of flour, and the top our number of batches. Now in our first column we're going to put 1 there for one batch, and to make one batch we need 7 cups of flour and 2 cups of milk. Now to form the numbers in our next column, we're going to take each one of these numbers in this first column times the same number. So for instance, we could multiply each of these numbers in this first column times 2. And if we did that, we'd have 2 batches of flour, or excuse me, 2 batches of muffins, and that would require 14 cups of flour and 4 cups of milk. Now there's nothing magical about multiplying by 2. We could multiply by other numbers. For instance, we could multiply each number in this first column times the number 5, and we get a new column in our ratio table. So take everything by 5, we'd have 5 batches. 7 times 5 is 35 cups of flour, and 2 times 5 is 10 cups of milk. So there's another column in our ratio table. Now there's no reason why we have to multiply by whole numbers. We could take any of these columns and multiply by a fraction. For instance, if we wanted to multiply by the fraction 1/2, that would give us the column 1/2 batches of flour. We could write it as a decimal 0.5. 7 times 1/2 is 3.5, and then 2 times 1/2 is 1. So this says that if we used 1 cup of milk and 3.5 cups of flour, we would make a half a batch of muffins. This column says to make, if we use 10 cups of flour and 10 cups of milk, 35 cups of flour, we would make 5 batches of muffins, and so on and so forth. Now here's the ratio table that we just formed, and let's note that this ratio right here, this original ratio of 7 to 2 appears in the first column, and in the second column we have this new ratio of 14 to 4. Because both those ratios appear in columns of a ratio table, we say that this original ratio of 7 to 2 equals that new ratio of 14 to 4. And so we say that these ratios 7 to 2 and 14 to 4 are equivalent. Now what that means in practical terms is that batches made with these ratios will taste the same. So if I use 7 cups of flour and 2 cups of milk, I'd get the same tasty muffins as if I used 14 cups of flour and 4 cups of milk. So let's look at how we can use ratios and this idea of equivalent ratios to solve some problems involving this muffin recipe. So let's suppose that we have 8 cups of milk. How much flour will you need to make a batch of muffins, and how many batches will this make? Okay? So here's our original ratio table. One batch of flour takes 7 cups of flour and 2 cups of milk. But now we have 8 cups of milk. And so we're going to put an 8 here in the second column of our ratio table. And so I say to myself, well, what can I multiply 2 by to get 8? Well, of course I could multiply 2 by 4 to give me 8. So if I multiply this last row by 8, well, I need to multiply all the other rows by 8. And so 7 times 4 is 28. 1 times 4 is 4. And so there we go. These top 2 rows give me my answers. If I had 8 cups of milk, I'm going to need 28 cups of flour, and that's going to make 4 batches of muffins. Now let's do just a slight variation on this problem. Let's suppose that we now have 21 cups of flour. How much milk will you need, and how many batches of muffins will this make? So we'll start off with the same ratio table, but now we want a 21 there in our second row. So I say, well, 7 times what is going to give me 21? Well, the answer is, of course, 3. So I need to multiply every number in this first column by 3. 2 times 3 is 6. 1 times 3 is 3. And so there we go. This says that if I have 21 cups of flour, I'm going to need 6 cups of milk, and I'm going to be able to make 3 batches of muffins. Now, there's different ways, different tools that we can use to work with ratios and equivalent ratios. The tool that we've been using so far is a ratio table, but there are other tools. The second tool that we'll use later on in this chapter is pictures. And so a simple picture of this ratio of 7 cups of flour to 2 cups of milk would look like this. We're going to draw 1 box for each cup of flour there, so we've got 7 boxes, and then 2 boxes there for our cups of milk. And so there's a simple picture that describes this ratio of 7 to 2. Now, the book will talk about some other tools for describing ratios, like a double number line and some graphs. We're not going to talk about those in this lesson. We're just going to focus on ratio tables and pictures. And really in this section we're only using ratio tables. Later on we'll use pictures. Now let's do another example to illustrate how we can use ratio tables to compare some different mixtures. So consider these 2 mixtures. We have, in the first we have 2 tablespoons of lemon juice and then 3 cups of water. And in our second mixture we have 5 tablespoons of lemon juice and we have 7 cups of water. So in both of these mixtures we have 2 quantities, there's a relationship involved, and so we have a ratio between lemon juice and cups of water. So the question that we want to try to answer here is, which question is more lemony? Well, if we just look at our mixtures here, we notice that this second mixture has more lemon juice, but it also has more water. So this would make it more lemony, but this would make it more watered down. So it's kind of hard to compare these 2 mixtures in the way that they are. So we're going to use a ratio table to get some different equivalent ratios and then compare those equivalent ratios. So here's our ratio tables that we're going to start off with. Here's our first mixture where we have 2 tablespoons of juice to 3 cups of water. Second mixture we have our 5 tablespoons of juice and 7 cups of water. And so let's form some different equivalent ratios for this mixture 1. So for instance, let's take this first column times the number 2. And so then that would mean we'd have 6 cups of water and 4 tablespoons of juice. Well, let's just take a step back. Does that do any better? Does that help me out any? Well, look, if I compare this to this, we've still got more juice and more water down here. So this equivalent ratio here doesn't really help me out any. So let's try a different equivalent ratio. Let's take that first column times a different number like 5. And what does that give me? Well, now I'd have 10 tablespoons of juice and 15 cups of water. Okay? Well, now look what we've got. We've got more juice here and more water than what we had down here in mixture 2. And what does that do for me? Well, stick with me. You'll see what we're doing here. Let's look down here at mixture 2 and get a different equivalent ratio for mixture 2. Let's take this first column times 2. Now what does that do for me? Well, now I'd have a 14 down here and I'd have a 10 here. So now let's compare these ratios right here. Notice that they have the same amount of juice, but notice that this has less water. So we're going to water things down less here in mixture 2 than in mixture 1. So that means that mixture 2 is going to be more lemony. There's our answer. Mixture 2 is going to be more lemony because it requires less water for the same amount of juice. So there's a simple example of how we can use ratio tables to compare some different mixtures. So that's it for the section 7.1 lesson. Your assignment for class is to read section 7.1.